Okay, so today we are going to solve systems of equations by substitution using a method that I like to call clean and messy. And what we're going to do is we're first going to make ourselves a little chart, a clean and messy chart. And we're going to look at our two equations and we're going to say which one's the clean one. Well, the clean one is always going to be the one that has a variable equal to something. Okay, so let's write our clean equation over here and our messy equation under the messy column. Okay, so what we're going to do is we're going to take x, and x is equal to 2y minus 3. And we're going to sub it in for this x. So we're going to take all of this, because that's what x is equal to, and we're going to put it in the place of x. So we're going to rewrite our equation 2 times, but now instead of x, we're going to put in 2y minus 13, because that's what x is equal to. And remember, we've still got plus y, and that's equal to negative 1. Okay, so now we've got to do some distribution, something that we should all be comfortable with at this point. So we got 4y minus 26 plus y equal to negative 1. Now let's combine our like terms. We get 5y minus 26 equals to negative 1. Add 26 to both sides. The 26's cancel and we're left with 5y is equal to 26 minus 1, that's 25. Divide by 5 on both sides and we get y is equal to 5. Okay, so we've got y, but now we need x. So we just have to sub the y into this equation because that will give us x. So we write down here, let's rewrite x is equal to, and remember we're subbing it in for y. So x is equal to 2 times, well y is 5 minus 13. So x is equal to 10 minus 13. So x is equal to negative 3. And we write our solutions as an ordered pair. The ordered pair is negative 3, that's our x value, 5. That's a point. So remember, what are we doing here? Well, we're trying to find the point of intersection of these two lines. This is an equation for a line, and this is an equation for a line. So we've got two lines, and we're wondering, do they intersect? We use substitution, we got this point. That is a point that will be on both of those lines. So what does the graph look like? It's the intersection of two lines, right? And let's even, we can draw a picture and we've got a point here where those two lines intersect. Okay, let's do the next one. So we're going to make ourselves, let's use orange this time, clean and messy. Make ourselves our chart. Okay, well which one's clean? This one's clean. All right, we've got a variable equal to 4/3 x minus 7. And the messy one is going to be, oops, let's just still use the same color, 3y equal to 15. Okay. So we're going to take what y is equal to, and we're going to sub it in for the y in our messy equation. So we'll rewrite our equation, 4x minus 3 times, instead of y, we're now using 4/3 x minus 7, and all that is equal to 15. So we've got to distribute that 3. 3 times 4/3, that's minus 4x. Negative 3 times negative 21, that is equal to positive 21 and equal to negative 15. So now 4x minus 4x, that's 0x, right? Those cancel, and we're left with 21 is equal to 15. Is this a true statement? It is not. 21 does not equal to 15. So that means that we have no solutions. Meaning, and we'll write our here, no solutions. meaning we have two lines that do not intersect, right? And the only way we can have two lines that don't intersect, let's remember back, that means they have the same slope, so they are parallel lines. Okay, and then our last example, we'll use green here. Let's make ourselves a clean and messy table. Well, we need to make one of these clean. So I'm going to pick this one. So let me just move down here, rewrite my equation. I'm going to bring my 2y over. So I'm left with x is equal to negative 2y plus 8. So that's the equation I'm going to use for my clean. Remember, I wanted to get one variable and then equal to something. And now that's going to be my messy. Okay, so let's remember, we're going to take what x is equal to, we're going to sub it into that equation for x. So we rewrite our equation, y plus 1/2. Now instead of x is equal to negative 2y plus 8, and that is all equal to 4. So we've got to distribute, we're left with negative y, and then 1/2 of 8, well that's 4, and that's equal to 4. So y minus y, that's 0, and I'm left with 4 equal to 4. That's a true statement, and that means that I have infinitely many solutions. And why is that? Well, because if we graph these two lines, we are going to get a line, and then we're going to get another line right on top of that line. It is the same line. It's a line on top of a line. Well, a line is made up of millions and millions, infinitely many points. So if you have a point on top of a point infinitely many times, it means that you have infinitely many solutions. And that concludes our video.